Deep in the heart of China, scientists are working on an ambitious project, creating an artificial sun. This isn't science fiction, it's called the Experimental Advanced Superconducting Tokamak, or EAST. The goal? To replicate the process that powers our real sun right here on Earth. You might be thinking, why would we need another sun? Well, our current energy sources, like fossil fuels, are polluting our planet. They're also finite, meaning they won't last forever. This is where EAST comes in. It promises a future of clean, limitless energy. The idea is to harness the power of nuclear fusion, the same reaction that makes the sun shine. Fusion involves smashing together light atoms like hydrogen to create helium, releasing enormous amounts of energy in the process. If successful, this project could revolutionize the way we power our world. It's a glimpse into a future where energy scarcity is a thing of the past. Stay tuned as we delve deeper into the science behind this groundbreaking endeavor. The sun's energy comes from a process called nuclear fusion. Imagine tiny particles much smaller than atoms colliding at incredibly high speeds. These collisions fuse the particles together, releasing a tremendous amount of energy. This fusion reaction is what makes the sun incredibly hot and bright. It's the same process that scientists are trying to recreate in the EAST reactor. Of course, replicating the conditions of the sun is no easy feat. The sun's core, where fusion occurs, reaches temperatures of millions of degrees Celsius. Creating and containing such extreme heat on Earth is a massive challenge. To achieve this, scientists use powerful magnetic fields. These fields act like an invisible cage, trapping the superheated particles and keeping them from touching the reactor walls. This is why EAST is called a tokamak, a Russian acronym for toroidal chamber with magnetic coils. The EAST reactor is a marvel of engineering. It's a donut-shaped device lined with superconducting magnets. These magnets generate a powerful magnetic field that confines the superheated plasma, a gas-like state of matter where electrons are stripped from atoms. Inside the reactor, scientists inject hydrogen isotopes, deuterium and tritium, and heat them to millions of degrees Celsius. At these temperatures, the hydrogen atoms overcome their natural repulsion and fuse together, releasing energy in the form of heat. One of the key achievements of EAST is its ability to sustain these extreme temperatures for extended periods. In 2021, the reactor set a world record by maintaining a plasma temperature of 120 million degrees Celsius for 101 seconds. While this is a significant milestone, it's important to note that the amount of energy produced is still less than the energy required to heat the plasma. The goal is to eventually achieve a state of ignition, where the fusion reaction becomes self-sustaining, producing more energy than it consumes. The potential benefits of fusion energy are enormous. For starters, it's incredibly efficient. A small amount of fusion fuel can produce a vast amount of energy, much more than traditional fossil fuels. Fusion is also a clean energy source, producing no greenhouse gases or long-lived radioactive waste. This makes it an attractive solution to combat climate change and reduce our reliance on polluting energy sources. Moreover, fusion reactors are inherently safe. Unlike nuclear fission reactors, which pose the risk of meltdowns, fusion reactions can be easily stopped. If there's a problem, the plasma simply cools down, and the reaction stops. While there are still significant challenges to overcome, the pursuit of fusion energy is a testament to human ingenuity. If successful, it could usher in a new era of clean, abundant energy, transforming our world for the better. The quest for the artificial sun is a journey worth taking, one that holds the promise of a brighter future for all.